This is a short video on experiment 3, resistors and capacitors. So let's start with part B, discharging a big capacitor. And if you look in your lab manual, you'll see there's a circuit diagram here. Well, it's actually, we put photographs of the different components in there. And we've also given you a schematic of what that circuit looks like. For setting it up, obviously you're going to want to look at both of these, but let's make sure we can identify the different components. So you can see we have the X-Tech power supply, a knife switch, and we're using Logger Pro here to actually do the voltage measurements. We have the RC circuit board and also an additional capacitor, a large capacitor that's used for this part. And if you look over here on the bench, I've kind of rearranged things. Here's the X-Tech power supply, that knife switch, Logger Pro with these leads plugged into it, which will let us measure the voltage. Here's our large capacitor and the RC board. And you should also make sure that you have one of these sheets that identify the values of the different components. You'll be wanting to have certain resistors in here, which you'll be able to figure out more easily with that sheet. So let me go and set this thing up, and then we'll take a look at the circuit. So here you can see the circuit for part B partly set up. We still got a fair ways to go, but let's take a look at it at this point. So at this point I've got a banana plug coming out of the power supply here off the positive lead. It goes to the switch. I'm going to open that switch up. It comes out of the switch. You can follow the wires around. You should do this with your circuit. It goes into the one end of the 1 k ohm resistor, brown, black, red. Comes out of that resistor, goes over to the positive terminal with the red here on the capacitor. And it goes through the capacitor, back out the capacitor, and goes off to the negative terminal of the power supply. Now if we look at our circuit diagram here, we've still got a fair amount to do, but we just basically built this part of the circuit through the switch, through the 1 k ohm, out of the 1 k ohm, which is this lead right here, through the capacitor, and back to the power supply. So we still need to hook in some other leads. You'll see there's a connection here across this 300 k ohm resistor, and there's also these voltage leads which go across the capacitor. So let's hook in the rest of those components and take a look at the final circuit. Alright, so we finished putting that circuit together, and it's a bit more complicated now. We have some more wires, but let's just point out a few things. So here we have leads coming out of Logger Pro, and you can now see them going in, positive and negative. They're measuring the voltage across the capacitor, which is what you're going to be measuring, the main thing you're going to be measuring in the circuit. And we also have added these two wires here, which also are connected across the capacitor, and they're now going to, you can see there's an orange, black, yellow, that's a 300 k ohm resistor, which once we open the switch, that's actually what the capacitor will be discharging through. So I've got the switch open and power supply off, and that's generally the way you will want to set up your circuit also. And it's good to do it something along the lines that I showed you, one step at a time. So let's turn on that voltage and let's see how this experiment works. Alright, so in order to start, you'll need to fiddle with the voltage here until you get about 9 volts, and you may have to turn up this current knob a little bit to get it to work properly. And it doesn't have to be exactly 9 volts, but keep it below 10 volts for sure, and you should be able to get it like 8.9, 9.0 or 9.1 pretty easily. And we've also turned on Logger Pro, and we're ready basically to take some data. I've already closed the switch, so our capacitor is charged up. Let's just hit collect and see what happens. Actually, I guess let's do it like the lab manual says. Let's open the switch and then come over here and hit collect on Logger Pro, and we'll see what it does. All right, you see the voltage is falling there. It's measuring about once per second, and it's set up to measure basically for 150 seconds. And what's happening is we charge that capacitor up to 9 volts, open the switch so it was no longer attached to the power supply, and now it's just attached to that 300 k ohm resistor. The charge that was on the capacitor is slowly leaving the capacitor, or leaving the capacitor at some rate, which is determined by the R and C of the circuit. So that's really all there is to this part. You continue to just let Logger Pro collect its data. You'll obviously want to copy that and save it and analyze it in a later part of the lab. And for part C of this experiment, you'll be measuring the voltage and impedance in an RC circuit. And in your lab manual, again, there's a sketch showing you how everything is laid out. We have 3-channel ground isolation unit, 4-channel scope, and our RC board. And here I've made note of what the components are. We'll want the 1 k ohm resistor and the 0.27 microfarad capacitor. We'll only be using the first 2 channels of the ground isolation unit, and we'll be using the first 3 channels of the scope. So let's identify the capacitor first. That is a 0.27 microfarad capacitor. It's the second one on the top of the board. And that 1 k ohm resistor that we'll need is brown, black, red. It's also indicated. It's over here on the board. So let's hook that up and then take a look at the circuit. We started to wire up the circuit for part C. You can see that we've got this coaxial cable going to the wave generator. It comes out of the wave generator, goes over to this T. One side of the T, or one line, goes over to channel 3 on the scope. The other side goes over to BNC to banana connector, and you can see there's a red lead going to the capacitor. This is our 0.27 microfarad capacitor. The other side goes to a black lead, which is connected to the 1 k ohm resistor. 1 k ohm resistor, the red lead, comes out and goes to the other side of the capacitor over here. So we've got a complete circuit formed with the wave generator connected up to the R and the C. Here we are a little bit later in the process. We've now got the 3-channel isolation amplifier hooked up. Actually, we're only using the first 2 channels. So let's do the easy part of this first. The output from this amplifier is on the bottom. It's this BNC connector. We've got that hooked up to channel 1 on the scope. And the output of channel 2, this other BNC connector, goes off and is connected to the input of channel 2 on the scope. And then you'll notice here channel 3 is hooked up. That goes off to the wave generator. So we've got the capacitor, resistor, capacitor, and finally the wave generator hooked up here. Now the other part of the isolation amplifier, of course, is the input, and here you'll see 2 banana plugs on top. That's the input for channel 1 on the left here, and there's 2 banana plugs here for the inputs to channel 2. So here I've twisted the BNC lines together. Sorry, I've twisted the banana lines together. And you can see they're going off here, and they're hooked up across the resistor, so red to red, black to black. So that input to channel 1 is going across the resistor. And channel 2, again, I've twisted these together to help you kind of see what's going on here. Those are going across here. You see the black and the red going to the corresponding red pin on the bottom and the black pin here on the bottom across the capacitor. So channel 1 is the resistor, channel 2 is the capacitor, and the outputs are going to the scope. So notice everything is off, the amplifier is off, and the scope is on. Let's go ahead and power up the scope. And we can also turn on the isolation amplifier. What that's doing is it's letting us measure the voltage without grounding out into the inputs. And you see its power lights now on. And as usual, the scope is going to go through its set of setup protocols. And it'll be ready in a minute here, and then we can see what happens. So here, what's happening in the circuit is the signal generator from the scope. This line right here is going to apply a voltage across both the R and the C. And then that's going to appear, that drive voltage is going to appear on channel 3. And then the other voltages, channel 1 and 2, are going to be across the resistor and capacitor. And so right now you can see the scope is lit up on all 4 channels. We really just need 3 channels. So we'll just push this channel 4 off. So now we just have channels 1, 2, and 3 lit up. And we can see on the scope the yellow, green, and blue traces corresponding to channels 1, 2, and 3 respectively. And nothing much is going on right now. That's because, well, we haven't turned on the wave generator. So wave generator is this button right down here. You turn it on, it'll start to glow blue. And now you can see actually on the scope that we're getting an output from the wave generator. And we've got a voltage across channel 1 showing up here. That's across the resistor. And there is a very small, barely noticeable voltage across channel 2, which is the capacitor. What we want to do now, just by way of understanding or showing you what it's going to do, is we want to adjust the frequency of the wave. You might be wondering what frequency is it right now, but we're not really set up to measure that. But you can see the time scale here is 20 microseconds, and actually you can look down here and see that we're applying, you might be able to see here, 25.6 kilohertz frequency. So let's change that. We are also, you can see here, applying a sine wave, which is what we want. And so actually these keys became active when I pressed that wave generator button. Let's press this button, and that makes the frequency active, and it lets me now adjust it. So I can adjust it by turning the control knob. Just sweep it, and here you see I'm going lower in frequency, and you can see actually that the voltage across the capacitor, I'm going to change the time scale here, the horizontal scale. You can now see that we've got considerably more voltage across the capacitor, and you might have noticed that the voltage across the resistor has come down. And if I go down to lower and lower voltage, I'm now at about 830 hertz. Actually, you can noticeably see, well, the frequency has changed. Obviously, let me again change the horizontal control, so you can see a few cycles. But now you can see, unlike when we started, the voltage across the resistor is smaller than the voltage across the capacitor. If you think about it a little bit, at low frequencies, we'd expect most of the voltage across this RC circuit to be across the capacitor. So in this lab, what you're going to do is measure these voltages and record them as a function of frequency, and then you'll be able to see, or be able to figure out how much the impedance of each component changes with frequency. So that's it. Quick look at the RC circuit in experiment number 3.